So today we move on. There are a few important areas which we need to discuss and then move on to Java 8. So the topic we'll take today and quickly finish it. It may take us a day or maybe 2 days, depends on you. The topic is exceptions and how do you handle exceptions in Java. Important topic, and any Java programmer should know what is an exception, how to handle an exception, what are the different kinds of exceptions, why do they come, how do you tackle them, what is try, catch, finally, and things like that. You should be familiar with this. Achha, there's one thing which has come out in the last 15 days or 1 month, which is emerging. A lot of companies, while they say they don't mind which programming language you use, Python, C++ or Java, a lot of companies, for some reason, it beats my imagination, have started insisting on Java only. So you need to be, you can do Python, you can do C++, but you should know Java well. Because some of these platforms, especially these platforms which companies use to recruit, they are only saying we will support only Java. As if it is I think the argument they give is that certain things become easier to do, let's say in Python, and then it is not a level playing field. So in order to create a level playing field, that everybody must use the same language. Then the differentiation between people becomes clear. Otherwise, somebody is writing code in Python, then he gets easily, for example, the slicing and dicing which you have in Python, or the quick summation that you get in Python, that's so much ahead that people do it very fast, and then the Java guy is at a disadvantage. So they're saying do Java only, and that they are allowing Java 8, but that's it. So they are saying whatever you do, Java should be the way you should write code. Okay, so what is an exception? Well, I think some time ago I had discussed what is the difference between an optimist program and a pessimist program. Briefly, what is it? If you have a programming style where you write 10 lines of code, then it is easy to read, easy to understand. But the problem with that code is, it's like expecting a sunny day scenario. Suppose you are opening a database in the first line, then you are opening a file in the second line, and then you are reading from the database in the third line, then you are reading from the file or writing to the file on the fourth line. You are kind of assuming that successfully you are able to open the database, successfully you are able to open the file, successfully you are able to write to the database or read from the database or write to a file. Now, while everything will go right if you give the right username, password, URL, all of that, there is every possibility that when you try to open a database and you give a wrong password or you give a wrong port number, the database connection will fail. Now, when your database connection fails, what happens? Should your program react by saying, just bomb out, giving a stack trace on the screen? That looks nasty, isn't it? That some program is, because it's not able to get a connection to a database, it just bombs out and says, I am not able, it doesn't say anything. It just prints some garbage and some gibberish on the screen. That is very disturbing. That's not how a professional programmer must write code. He should give in case the program is not able to open a database, he should give a proper message saying, I am unable to open the database for this reason, or I am not able to open a file because of this reason. Now that is a sensible message. If you don't give that kind of a message, the person who is using your program gets confused, doesn't understand what really is happening in the program, what did he do wrong. And even bewildering here is that, yesterday the program was working, today it is not working. Maybe something went down, database went down, or maybe the URL changed, something went different. And the user who is using your program, your customer, doesn't understand what is happening. And that is cruel, that is unprofessional. So exceptions enable you to give sensible messages to the user saying this is what went wrong. or this is why the program is not able to progress or proceed. That is very important from a good software engineering practice, that sensible messages must be reported to the customer so that the customer doesn't get upset and can tell you what really went wrong. Your message will help you debug tomorrow. So the act of giving proper messaging is one of the benefits of exception management. The other benefit is obvious. When something goes wrong, how do you go about correcting it is also exception management. We really don't correct it, we detect it and give sensible response. Response could be we log the error. One thing is we give a nice message to the user. The other is we log the error very systematically in some log file, so that tomorrow somebody who analyzes the log file will come to know what went wrong, what event happened, and that's again a very useful aid for somebody who is maintaining our program, right? So that is again a thing which exception management performs. The ability to write a log, the ability to give a proper message. Then there is also the whole idea of handling exceptions for the simple reason that I want the rest of the program to proceed. That is, in a certain part of the code, there was some problem, but that part of the code is not very critical. It went wrong, it didn't work, but I will proceed with the rest of the program. Maybe that part didn't do, or it's like this. If I don't open this database, I'll open that database. If I don't open that database, I'll open some other database. I should have the way that if this is failing, I do something else, I do something else. A bad way of programming is what? When something goes wrong, the whole program aborts and abruptly comes out and says, I can't do anything. That is horrible way of writing code. There have to be alternates. If this is not happening, I do that. If that is not happening, I do that. Now, in order to have this happen, if one fails, I have to have the ability to handle that exception. And once that exception is handled, I do something else. So the ability to gracefully move from one option to another option to another option in case any one of these options is failing is also a benefit of exception management. So that is why we learn exception management in so much detail. Okay? And so I am just going to summarize 3 possible reasons why you handle, there are more than these, why you want to handle exceptions. A, something goes wrong, you want to give a sensible message to the user. B, something goes wrong, you need to keep a record of that error somewhere. That is called logging. 3, if something goes wrong, you want to try something else or something else. So in order to have the ability to exercise these options in our program, we handle exceptions. These are some of the fundamental reasons why a programmer learns how to handle exceptions. Exceptions is a part of life. It is going to happen in a program all the time, except when you write very harmless, very useless, this long. And when you are doing something productive, you will have a lot of exceptions and possibility of exceptions. Now, Java has a very, very categorical process of handling exceptions. No other language, whether it is Python, whether it is C#, I am not even counting C++ because C++ has exception management, which is like, if you compare it with Java, it is like comparing a 2-story building with a Qutub Minar. You know, if you give the comparison between the C++ way of handling exceptions and the Java way of handling exceptions. C++ is very primitive, very, very amateurish style of handling exceptions, and Java is, of course, one of the most professional and most well-defined way of handling exceptions. Now, Java has defined a whole hierarchy of exceptions. Being an object-oriented language right from the beginning, they have a whole exception hierarchy. The exception hierarchy starts from a class which is called throwable. Anything which you can throw, any system, anything which the system can throw at us is called a throwable. So the whole exception hierarchy is derived from throwable. So we have the throwable class, then we have the error class, then we have the exception class, and then we have a cartload of exceptions, thousands of exceptions, which are derived from this exception class directly or indirectly. Some are derived directly from the exception class, Some are derived from derivations of the exception class. So there is thousands of exceptions which Java comes with already. Now, do you need to know all the exceptions? No, you don't need to. You need to know certain standard exceptions, and depending upon what kind of library you are using, that will bring its own category of exceptions. For example, if you are using an image processing library in Java, there will be exceptions of their own kind. For example, you are asking for resolution of an image and the resolution is too big. It cannot be held in a data structure. It is an exception. You are doing something on a network and the speed of the network is not adequate and you are not able to send or flush your buffers. If you are doing that, there is another kind of exception. If you are dealing with files and you have some permission issue, that is another kind of exception. If you are dealing with, let's say, animation program and the animation is far too slow, or the sweep of the animation is not adequate, or the speed in which the direction is changing is not adequate, that is another kind of exception. So depending on what your program is doing, depending on the various modules you are using in a program, your exceptions will change. That's why I said there are thousands of exceptions. There are not hundreds also, there are thousands or tens of thousands. Because each different library you use, each different package you use, comes with its own set of exceptions, which are related to that particular domain. So Java has primarily, I would say 2, but I would like to say 3 major categories of exceptions. And we'll see all of them sooner or later. In the next couple of hours, we'll see some of them, and I hopefully will see the rest soon. So there are 3 major categories of exceptions, I would say. Java says only 2. They are unchecked exceptions, checked exceptions, and I will add my own category, which can belong to either of the 2, which are called user-created exceptions or user-defined exceptions. So primarily 3 categories of exceptions: checked, unchecked, and user-defined. Now user-defined is my own category. It is not an official category. User-defined is exceptions which have been created by us, defined by us, and which can belong to either checked or unchecked. Okay, so that is how the exception family is broadly categorized. Now before we start working with it, I will crudely define what is an unchecked exception and what is a checked exception. Achha. This unchecked exception is often called as a runtime exception. Some people call it unchecked exception, some people call it runtime exception. And then there is this checked exception. Okay, what is the difference? Basic difference. You'll understand it as we write code and demonstrate code, but what is the fundamental difference? Fundamental difference is simple. A checked exception means the compiler, Java compiler, by the way, before we get in here, this Java compiler, especially with exception handling, is a very particular guy. He is very micromanager. So you forget to handle a particular exception, he will not allow your program to compile. So an unchecked exception is where Java compiler takes the view, you handle it, you don't handle it, your problem. That is what is called an unchecked exception, where Java doesn't care whether you handle it or don't handle it. If that kind of exception is there, that is called a runtime exception or unchecked exception. What is a checked exception? A checked exception is that which, if you don't handle that exception in your program, if you are not made provision to handle this exception, then Java says, no, I will not allow your program to compile. You first handle that exception. You either decide what you want to do with that exception. Till you decide that, I will not allow this program to compile. This gives Java a very bad name, because a lot of people I have seen, when they see that irritating line that unchecked exception not handled, they leave programming. Okay? No, not really, but often it's very irritating. So what is a checked exception again? An exception which ought to be handled by you as a programmer, and if you have not handled it, Java compiler refuses to compile your program. It says there is a checked exception expected and you are not tackling that exception, I will not allow your program to compile. That is why it is called checked. Java compiler is checking your code and seeing whether have you made provision for handling this exception or not. If you have not made provision, I will not allow your program to compile. Simple. Unchecked exception, I don't care. It's your program. If you don't catch it, don't handle it, it's your problem. I will not bother. So that is called an unchecked exception. So we will start our story by doing unchecked exceptions, and soon we'll move on. We'll learn the basic story of exception management through unchecked exceptions, and then we'll come to checked exceptions and learn how to handle checked exceptions. So that is how we'll proceed. Okay. So these are, okay, I think this picture summarizes it well. I think this is a good slide. So types of exception. User defined exceptions is one category which can be either checked or unchecked. And then there is a built-in exceptions. Built-in means those which come along with the language, which come as part of Java language, Java libraries, Java language. So the unchecked exceptions are arithmetic exception, class cast exception, null pointer exception, array index. We'll see some of this. The checked exceptions are class not found, interrupted exception, IO exception, SQL exception, and many more. File not found exception. We'll also see some of these. Okay. This is the general, very common exceptions have been listed there. There are many more, especially on the checked exception. The unchecked exceptions are few, but checked exceptions are thousands. Okay. And user defined exception, you can define it. It can be a checked or an unchecked, depends on you. You can create either of the two. So it depends on how you want to create your exception. Okay. So the best way to do it is to start writing code. Okay. And talk about exception. So we will start with something very simple. So int a equal to 5, int b equal to, let's say, 0. Then we'll say int c is equal to a by b, okay. Yeah, you can, I don't know which program is this, A12 lab 1. If you want to type with us, which you should, otherwise you'll never get exceptions. Okay. So int a equal to 5, int b equal to 0, int c is equal to a by b, and we are printing c. Okay, so this is the code. Now just watch this code, and before we try it out, let's think about it. So we have a as 5, b as 0. So when you divide a by b, there is something wrong, isn't it? You can't divide things by 0. So in Java, this gives an exception. This is called an arithmetic exception. Okay. Later we'll see what is the class hierarchy of arithmetic exception. We'll see that in a moment. Now, my first question is, will this program compile? Yes, no. I am asking a very specific question. Will this program compile? I am not asking whether it will run correctly or not. Simple question is, it will compile? Okay. Yes, it will compile, because the kind of exception expected on line 5 is a arithmetic exception, and arithmetic exception is a runtime exception. All runtime exceptions are unchecked exceptions. Okay. We'll see how to visualize that, but the program will compile without problem, and however when we try to run it, it will erupt and give you a nasty stack trace, which is something went wrong, you know, all that bad kind of thing which happens, right? So we'll run it, it will run, yeah, and as you can see, it has come out with an error saying I have an arithmetic exception. See that, java.lang.arithmetic exception divided by 0. That is the name of the exception, or that is the message associated with that exception. Okay. So this is what happens. The compiler didn't check it, program ran, and it gave an exception which I had not handled. So it program just bombed out. When I say bomb out, what I mean is, okay, come back. I will say one more line after print line C. I'll say print system.out.println exited normally. Exited normally. Now this line won't be printed in this case. That is what I mean by the program just coming out without any proper exit. Okay, erupting, just program erupted. Okay, so just let's run it and check it out and see. You see, only that exception message has come. That has come from the JVM itself, from the Java what we call the Java runtime environment. The JVM has given us this error and said I can't proceed anything. You obviously did not exit normally. You exited abruptly with an exception called as arithmetic exception. Why it's an arithmetic exception? Because there is a divide by 0 is called an arithmetic exception. So that is the error. Now I'll close the thing and then now let's think about it. But before we think about it, what do we think? Let's analyze a little about arithmetic exception. What is this exception? What is the class hierarchy of this exception? Let's just quickly look at it. So we'll go to Google. You can also do that. Yeah, we'll say arithmetic exception. No, always look at 8. It doesn't matter here, but do Java. Think of Java 8. Java 5 is out of the window. Okay. So we have to be familiar with Java 8. Okay. So now just look at the exception hierarchy. Okay. Just walk through the exception hierarchy. That is the class hierarchy of exceptions. You see right at the bottom, arithmetic exception. It is derived from runtime exception. Can you see that? That's what makes it a unchecked or runtime exception. See that? Then runtime exception is derived from exception class. Only this family, that is this sub-branch, which is runtime exception, results in unchecked exceptions. If I had any other derivation from exception class, that would be checked. And if you see, exception class itself is derived from throwable, and like everything else in Java, everything is derived from object. That is no secret. Object is the primordial class from where everything gets derived from. So this is the class hierarchy. You should have a reasonable idea of this class hierarchy also. Okay, arithmetic exception, runtime exception, and exception, which is derived from throwable. Okay, just a mental picture should exist with you. Now, going back, as I said, it's a runtime exception. All runtime exceptions are unchecked exceptions. Now, suppose I wanted to not have this exception. I could do two things, correct? What I could do is, before ever I do division, I have to check whether the denominator is 0. Okay, that is, I have to take care. But Java says, we cannot expect every programmer, when he is performing a division, to write a code, if b not equal to 0, then only do this, else do that. That will make it a pessimistic code. That means this guy always is like very wary. He, before even doing a division, he is checking whether a by b, whether it will result in an exception or not. He is checking whether b is equal to 0 or not, any denominator is equal to 0 or not. If he is going to do all of that, and this is just one case. Similarly, when he is indexing an array, when he is looking at an array element, every time if he is going to check whether I is less than size minus 1 or length of the array minus 1, can you imagine how much of time this programmer will waste doing what? Doing this nonsense check. And more than that, the code that he will write in that case will have more of this nonsense of checking than actual code. So it's like saying, you know, you meet such kind of people in life also, no? Before taking a next step, you know, they watch, should I take this next step or not? Correct? It's a similar attitude. What it leads to is not bad decision making, but here what it leads to is a code in which more checking is being done and less of actual functionality is there. Or the functionality and the code checking have become khichdi. Okay? So anybody reading that code is not able to make out. And if you watch our try block, look at it carefully. Our try block has nothing in it, has only logic in it. There is no error checking ever in the try block. The try block is only for the basic logic. If it happens successfully, there is nothing else. The try block only will be executing, nothing else will execute. But if B was not 0, the C value will be printed and also will get a message exited normally. Now I am writing the try block, and with the try block, normally I will write a catch block, finally block, or both. I can write one of them, but I can write both of them. Normal practice is to write both. So we'll write catch. Now catch, okay. Now what kind of exception we are expecting? Arithmetic exception. So a little bit, now pause a bit and understand what I am saying carefully. Let's just analyze what happens on line 6, that is the A by B line. Just analyze what happens on the line, how the system behaves. Okay, I am describing it, try to get it. A by B is happening. Now, you know the JVM is seeing A by B, so the JVM is using the underlying operating system to do an A by B. Okay, so it passes A and B to the underlying operating system, whatever it may be. So once the underlying operating system gets this A by B, it does that A by B using what is called as the floating point division, floating point unit. It may do floating point unit. In this case, it may not engage the floating point unit because both are integers. It may use CPU itself, or rather I should say the ALU within the CPU. Remember, the ALU is sitting inside the CPU. So the operating system engages the ALU and says, Mr. ALU, here are two operands, A and B, please divide them and get me the quotient. Okay, I am interested in the quotient. Now the ALU tries to do an A by B. It is the ALU which is the first to detect, oh, this A by B is, I tried to do A by B on the ALU, and while doing the A by B on the ALU, because B happened to be 0, what happened? An internal trap, we call it an operating system trap. I don't know whether you have seen traps in OS, but this is called a trap. A trap is created, or an hardware interrupt is created at the OS level, because the OS is being alerted by the ALU that I can't do A by B, there's something wrong, so it's sending me a signal. Who is sending a signal? The ALU is sending a signal to the operating system. The operating system registers, oh, I have got a signal, that means I have got some kind of a hardware interrupt. That means something went wrong. And it analyzes what went wrong. And then the OS communicates this to the JVM, saying, I have got this kind of trap, this kind of interrupt, and now you report it to the program. So what the JVM does now is, at this stage, it creates an exception, because the way JVM tells you something went wrong is by creating an exception. So actually, somewhere in the JVM, there is a new being called on the arithmetic exception object, passing it some message. So can you imagine on line 6, internally, communicating happening to the operating system talking to the ALU, ALU giving the thing back and telling that there was a problem here, and this problem is now understood by the JVM, and the JVM is internally doing a new arithmetic exception. That is what it is calling, and creating a new arithmetic exception object, which it is then giving it to our program. So our program is getting a freshly minted arithmetic exception object. Once it does arithmetic exception object, what does our program do? It searches. It searches this code, seeing, is this code anywhere catching this arithmetic exception handler? Is there an arithmetic exception catch in the program? It says there is nothing. In the earlier case, it had nothing. So it said there is no way to handle me. I have an exception object now. The JVM has created an exception object. Once the JVM has created an exception object, there are only two alternatives. Either you trap that exception, or it will create a fire and bomb you out of the program. So if you don't handle that exception, it will just kill you out of the program. It will just throw you out of the program. That's the only way exceptions are done. So once an exception object is fired or created, it has to be, it's like a fire. It has to be either doused or it will burn your program. Okay? So either you douse it means put extinguisher on it, or that is called handling an exception, or it will burn your program. Now, in the earlier instance, exception object was created, there was no fire engine, there was no extinguishing. So what happened? My program bombed and I got thrown out, right? So now we are going to be a little careful and we are going to say catch. Look at the way I give the catch handler. I say arithmetic exception, the name of the exception, and give a reference to that exception. Now, wait. Now, just understand what happened. The exception object is even now going to get created because of the division by 0. Now, the JVM is going to search our program looking for, is this guy having an extinguisher for my kind of exception? So, my kind of exception is an arithmetic exception. Now, the exception object which has been created, because it sees line number 8, what does it do? It now assigns AE to that exception object. Now, can you understand? AE, that parameter AE of my arithmetic exception gets assigned, it's a reference now, to that arithmetic exception object which was just created just now because of A by B. This JVM created the exception object. It was just an object. We had no reference to it. So we couldn't catch it. So now when we had a catch and we gave this catch arithmetic exception AE, now AE is a reference to that exception object which was created. So AE is a reference to the exception object. So whatever exception object which has come, we can see it in AE. AE is referring to that. Now I will say catch. I will give a println first, just to say that my code is there. Println caught exception. First say caught exception. Caught exception. Some message, and after that I am going to say AE object itself has a get message. In every exception object there is a standard method, okay, because exception objects also are objects, so they also have logic. There is a standard method always available on exception objects called AE.getMessage, okay. So, or getMessage is a standard method which I am invoking. So I am saying AE.getMessage, whatever is the message which is coming with the exception, get me that message which is associated with that exception, and now I have caught it. So now line number 12, when it is encountered, the exception has been doused, the exception is extinguished, it is no longer on fire because it was raised on line 6, it was raised on line 6 and it was caught on line 8 successfully because it is the correct kind of exception, and after that once I caught the exception is deemed as finished. The fire is done, it's closed, and that's why when the compiler sees line number 11 or JVM sees line number 11, it says there is no problem with this line. This line, there is no pending exception, so you will get exited normally. You will get that exited. You are now normal because you got an exception, but fortunately or whatever, you handled it. You cleared it. And once the exception has been cleared, there is no pending exception. I am in good shape. So the code can execute normally after this. And any lines I put after this will execute as if nothing has happened. Okay. So let's watch this now. Acha, but one thing, line 7 will not be encountered. Line 7 will be exited, will not be Because what is going to happen? Exception is going to come on line 6. Once the exception comes, I told you nothing more. It's on fire till it finds an exception handler or doesn't find one. In this case, it found an exception handler. The fire was doused, but it has already exited the try block. It cannot come back into the try block. There is no re-entry option in the try block. The try block is gone. Once the exception has come, try block has been left. It has aborted from the try block, escaped from that try block forever. It will never re-enter the try block because it cannot. The line 7 will never be executed because there was an exception pending and it couldn't execute line 7 and it went into line 8 to handle the exception. But line 11 will be executed because when it came to line 11, there was no pending exception. Line 7, there was a pending exception because exception had been raised and not handled. It is getting handled only on line 8. And once you have exited the try block, you can't re-enter. Okay. So let's see what we get. Okay. Yeah. So the way it happened is, we caught the exception, we got the message divide by 0. This is our message which came from AE.getMessage, that part. It is our trap which is giving it. And then more importantly, it proceeded as if nothing had gone wrong. Exited normally. Do we get that? Nothing went wrong. Nothing is now wrong. It went wrong. It was corrected. Now, no more. All exception is cleared. Are we there? Did you understand this try and catch? Now, we'll understand it in more detail by doing more things. Okay? So, let's go back to the main code. Okay. Now, what is the kind of exception coming? Arithmetic exception, correct? Now, we will see one more exception. This time we'll create an array exception. Okay? Yes? No? Okay. So let's correct our B to 1 so that we don't have that exception. Okay? Let's also create a nice array there. So int ARR, okay, int ARR equal to new int, let's say 5. Okay. So we'll create a array of primitive elements, 5 element array. Are we there? Okay. No, yes. Understood? So we create a 5 element array 0 to 4, correct? Now let's try something brilliant, okay, which is ARR of 7. There is no ARR of 7, there is no ARR of 5 also, but let's just make ARR of 7 equal to 25. Now, this is what makes Java very robust. Many other compilers, many other runtime environments, including C and C++, sometimes actually this line will work. If you create an array of 5 elements in C++ and try to access the 7th element, it will work. Why? Because in C or C++, it's only a pointer location which is allocated as an array. If there is free memory available there, then it will occupy that memory. It will work. You will see many times in C++ program. See, even if you do ARR 7, it will work, though you have allocated only 5 elements. Why? Because in C++ there is no array. Remember, it's only a pointer and it's up to the programmer to take care that he doesn't go beyond the allocated memory. The system doesn't stop him. There is no block there. There is no end there. It's up to you. And this is often exploited to write viruses and all that, because by using your pointer intelligently, you can stray into areas where the operating system is there and corrupt the operating system or infect the operating system. This is a common trick used for writing viruses for long times. So this is a problem both with C as well as C++, because C++ carries the baggage with C. Some of the more modern C++, like what you see in Unreal, they have a different kind of management of the pointers. They have what are called smart pointers. Okay, smart pointers are more like Java references. They are a layer on top of the basic pointer mechanism that you see in these languages. They create a smart pointer layer which does both garbage collection also and which does this protection also. It doesn't allow you to stray beyond a particular size. But only some packages or some systems support it. Unreal is one because it cannot afford you to go into areas which you are not supposed to go. And there are some more packages which protect using this smart pointer thing. But then that is an extra burden both on the programmer as well as on the product creator to do this. Java, it's automatic. So now on line 9, again there will be an exception. This time it will be a different kind of exception. We will get that exception and understand a little bit more about that exception and then proceed. Okay, so let's run this code and see what we get. I hope you are also running. Okay, we are running this code. Yeah. Now we got something else. Now we got 5 on top because of the A by B, that there is no problem. And whereas when we tried to do ARR of 7, it gave us an error, and the name of that exception is, you can see there, array index out of bounds exception. A long name, but the name tells it all, that it's an index out of bound exception, and we got it because we tried to allocate or go beyond the memory which was allocated, beyond the allocated memory. That is why we got this exception, array index out of bounds, and this is an exception. Now, since we have got that exception, let's talk about how do we handle this exception. So let's go and check our reference. Whenever you get an exception, at least in the earlier days, please make it a point to go to the Google and look at what is the class hierarchy or any information you can get about this exception. Basically the class hierarchy. Let's look at the class hierarchy again for array index out of bounds. Okay. So let's look at it. Now you will see array index out of bound exception right there. It is a derived class of index out of bound. Now sometimes you get this exception with strings also. If you try to access a character which is beyond the length of the character, then you will get string index out of bound, which is another derived class of index out of bound. This is array index out of bound. But do you think something common? Do you see some commonality between the exception which we just saw, which was arithmetic exception, and the exception we are seeing now, which is called array index out of bound exception? Do you see something? Yeah. Both of them, arithmetic exception was directly derived from runtime exception, if you recollect, and array index out of bound is derived from index out of bound, which is derived from runtime exception. So both of these exceptions are checked or unchecked? Unchecked exceptions. They are runtime exceptions. As I said, some people prefer to call unchecked exceptions as runtime exception because they are directly or indirectly derived from runtime exception. We saw that. In arithmetic was directly derived from runtime exception, and this is one level below. But still, it is not, though it is part of exception class, all exceptions are part of exception, but they are subfamily of runtime exception. So that's why they are unchecked exception. That's why the compiler is not cribbing. It's allowing my program to compile. It is only at runtime that we are getting the error. Our program is running, and while running it is producing the exception. Okay? This is again a runtime exception. So it's not a checked exception. My program is allowed to compile. Now, how would I catch this? If I have to make provisions to catch it, what would I do? I would want to change the code, right? So now let's change the code a bit. So let's add one more catch block. Can we add any number of catch blocks? Yes. Just like C++, there is no limit on the number of catch blocks which you can have with a given try block. There is no limit. Look, it will look funny that you have many catch blocks, but it depends on you. It's your program, your privilege. So catch array index out of bounds, array index out of bounds. Okay. Let's call it AIB, AIB. Okay. Array index out of bound, AIOB maybe. Okay. Some name. So again, what is happening? Same thing. When the array index out of bound, Java runtime environment sees it or JVM sees it, at that time again an exception object is created. This time what kind of exception object? Array index out of bound exception object. That exception object is created and a reference to that object is passed to AIOB and your current program is halted. Okay. So if I put a line after ARR 7 saying system.out, okay, saying array accessed or something, array accessed, will line 10 get displayed? Will it work? Yes, no? No, by the same token, line 10 will not be executed because it's in the try block, and once an exception comes, the remaining lines in the try block are aborted automatically. There is no way they can ever be handled because now you are on fire. Till that fire is handled, you can't do anything else. You can't think of anything else, right? You are on fire. So once line 9 is encountered exception, line 10 will be aborted and okay, we'll say out of bounds exception, caught exception. We'll just put an error message slightly different. Actually, you can put a better message, but that's okay. You can say your array is too small or something, more user-friendly message. So you are now going to get an exception on line 9 and then you are going to get exception raised, exception object created, and then the JVM is going to search in your program where is the exception handler for it. If it finds one, it will go there, and if it doesn't find one, it will say not found, which is what was happening just before, and our program will come out. Now we don't want that to happen, so we have a nice exception handler there. Okay. So now I have this exited normally will come, and because at that point line 17 there will not be a pending exception and exited normally will come. So and also the details of the message will be of the exception will be printed because I am using the same get message method which is available on every exception object. I am using that method and I am printing whatever is there. Okay. So let's run it and see what we get. Okay. So here we are. Okay, that 5 came, earlier 5. Then array index out of bounds, caught. This is from our thing. And the message which was sent along with that exception had the index which was malfunctioning, which is 7. So AE.getMessage or AIOB, whatever, the message which came with that was 7, just 7. Okay. So I printed that 7, and do you see that exited normally? Yes, because by the time that line was executed, there was no pending exception. So that's how the try and 2 catch blocks work. Did you understand this much? No? Yes? So far so good? Shall we move on? Okay. So we have 1 try block, 2 catch blocks. Why are we having 2 catch blocks? Because we are expecting 2 kinds of problems. So if you are going to expect 20 kinds of problems, you will have 20 catch blocks. Agreed? If your code, try block code is quite complex and quite intricate, then you will have 20 possible catch blocks. Because if you want to handle each exception differently and want to write code for that specific exception, you need to have those 20 catch blocks. Correct? Done. Now, proceeding further, I have one try and possibly many catch blocks. Now, often the requirement is, well, there is a possibility of 20 exceptions, but you know what? I am a bit lazy, so I really don't want to deal with each different kind of exception differently. I'm lazy person, call me whatever you want, but what I want to do is, I don't want to write these 20 handlers. I want to write one handler which can handle all these exceptions and give me a generic message, something is wrong with your program. That's it. I'll figure out. Are you with me? Can you appreciate that point, concern? I don't want to write different exception handlers. I just want to know something went wrong. I'll figure out looking at the code later what may have gone wrong, or on demand I will then write many exception blocks and all that, right? Or I am so convinced I am such a perfect programmer that I just want a generic handler and I'll manage. I'm a perfect guy. I won't have. Is there a way, rather than giving detailed handling of exceptions, that is potentially having 20 different kinds of exception handlers, can I not have a generalized or a generic exception handler and use that? There, yes, of course you can. And how do I do it? To understand what really is happening here, you have to go back a little into our Java class and class hierarchy. Remember, I had made a statement which I had asked you to not forget forever. What was that statement? Yeah, what was the statement? Excellent. This guy is going to go somewhere. Okay. So, there is one statement which I made. I'll repeat it again. I had made a statement which I said, and he very nicely remembered, you should never forget when you are doing Java programming or any object-oriented programming. Even if you are programming Unreal or you are programming on any other platform, you should never forget this line. What is that line? Base class reference can point to derived class object, vice versa is not allowed. Any base class reference or pointer, we call it reference in Java, any base class reference can point to any derived object, derived from that base class. So, now, little while ago, I drew your attention to a very important point, which all of you agreed, which is what? That whether it is array index out of bound exception or arithmetic exception, they have a common hierarchy. Both of them are derived from runtime exception. Both of them are derived from runtime exception, which potentially from an object orientation means a runtime exception reference can be assigned to either an arithmetic exception if it comes, or a array index out of bound exception if it comes, because these are all derived exception classes and the base class is runtime exception. Do you all agree? We are just borrowing something which is a essential object orientation 101 and which says some basic principles about object orientation, which says base class reference can point to derived class object. We are just going to use that. So, now let's revisit our code for a moment. Now, you see we are having two catch blocks. Potentially, imagine in your mind there may be 20. And let us say all of them are runtime exceptions. So, I can cleverly write one line at the top of all exception handlers. Catch runtime exception, RE, let's call it RE or RTE, whatever, okay. And I will say there, print, okay, some runtime exception caught, we don't know what, because we are just catching it. right? Some runtime exception caught, and against that we are going to say along with that RTE dot get message. Okay, so now you will see something interesting happening. Okay, go to the left. So how many catch blocks do I have? 3. Okay, but I have 1 block and then I have 2 blocks. Now if you look at this code, forget exceptions for a moment, or remember exceptions. Now this code, does it look something about the order of the exception blocks? Is it not sounding a little or looking a little absurd? No, what I am saying is just look at line 12 through line 20. Look at the order of my catching of exceptions, order of my catch blocks. Just look at the order. Do you find something jarring, something wrong? I am sorry?
Generalized exceptions will be downer.
Good. You know what is happening? At the top, I have a generalized exception handler. That guy will anyway catch the exception. And once the exception is doused, what is the purpose in having the detailed exceptions below? Are you with? It is like I was searching for a doctor. I had pain in the chest or I had something, okay, and I found a doctor. Beyond him there was a cardiologist. The doctor met me, the doctor told me to do something, I am doing that. I will never see the cardiologist, no? You are getting what I am trying to say? You have to understand. I found this guy, he handled it. Because he is a doctor, not a veterinary doctor, regular doctor. So he handled my problem. Once the problem was handled, there is no more problem. What are those idiots standing behind him? There is a cardiologist standing behind him, there is a kidney specialist standing behind him. What will they do? Isn't it that procession should be ulta, no? If I have a heart problem, cardiologist will handle. If I have kidney problem, kidney guy will handle. If I have something else, then that general doctor can handle. Now I am putting the general doctor before. What is the cardiologist going to do sitting there? Nothing. Are you getting me? So, generalization, if it is there, should not be in the beginning. Otherwise the generalization will catch it and handle it, whichever way it handles. And the specialized handlers will never be encountered by the code, because once the fire is doused, it is doused. Over. However it is doused. Some exception handler has to catch it. The generalized exception handler will catch it. And he will say, now there is no more exception. You just wait. Nobody. It is like the first guy caught it. The other guys have to just suck their thumb all their life, right? These two guys, the guys at the bottom, they have no work, they will never have any work to do. Do you agree with me or no? Because the first guy will tackle the exception and finish the exception. There won't be any pending exception. So this is a wrong order. Now cleverly, Java also knows that this is a very common mistake, where programmers which are immature or untrained put this runtime exception before, or a generalized exception handler before specialized exception handlers. What we have done by mistake. Okay. Now this the Java compiler will catch. It will say something is wrong with the way you have handled the exceptions. Okay, the way you have caught the exceptions. So let's see what. Please do it and see. That's seeing is believing. So yeah, you get a compilation error now, which says arithmetic except for both the exception handlers. It says arithmetic exception is caught and array index out of bound is caught. Who caught it? The runtime exception guy caught it. So there is no point in compiling this code. We have written some junk. I am not going to compile it. Okay. Java compiler is very strict that way. So here the Java compiler says this is wrong, these exceptions are already caught, there is no point writing these exceptions. See? No, yes, okay. Now, how should you write them? Well, let's write the runtime exception. Let's remove the array index out of bound exception. Let's let the generalized exception handler hold it, catch it, and we will move that above, or we'll you can yank also, yeah. Okay, so we shifted it in the correct order. So in my code now, arithmetic exception comes first, yes, specialized guy comes first, and if he is not handling it, and there is a runtime exception, then the runtime exception handler will handle it. Are you with me? Yes, no? Everybody understood? This is, order is correct. Now what kind of exception is going to come in our program? Arithmetic exception is not going to come. Which exception is going to come? Array index out of bound. Arithmetic exception, we already corrected that code. So array index out of bound is going to come. Because array index out of bound is going to come, then what is going to happen? Now there is no array index out of bound handler. We removed it. Who is going to catch it? Runtime exception. Because base class reference can point to derived class object. So RTE will point to new array index out of bounds exception. Are you imagining that line in your mind? RTE is equal to new, meaning the new exception object which was created because of the JVM exception handler, exception object, that is pointed to by RTE, which is correct pointing, because RTE is a base class exception handler and can always point to derived class. Okay? So just like those of you are attending Unreal, a character class reference can refer to a pawn. There is a pawn, right, in Unreal, and there is a character. Actor is the base class, I am sorry. Pawn is derived from actor and character is derived from pawn. So an actor can point to a pawn, an actor can point to a character. Base class is actor, okay, primitive. Okay, so now we have here the arithmetic exception handler which will not be accessed, runtime exception which will be accessed. So let's run it and check, and exited normally will come because the exception is handled. Okay. So we got this message 5, some runtime exception caught, and the message which came along with that exception, which is still 7, because remember it's still an array index out of bound exception. And then we also got exited normally, because at that point there is no pending exception, exception has been doused. Okay. Okay, so I think I'll give you, because some of you are getting little restless, I'll give you a 10-minute break, and we will break for 10 minutes, again start. Okay. So we will continue. So just now we saw that we can have a generalized exception handler, but that generalized exception handler should be at the end. It cannot be before. Otherwise Java compiler will give you a compilation error and refuse to compile your program. So we need to have more than one catch blocks, and you can have, and they follow a class hierarchy. That is what we have understood. So now we will take one step forward. We are still going to work with unchecked exceptions, okay, for the time being. We'll introduce checked exceptions in a little while. But before that, we have one more idea to cover, and that is something which you don't see at all in C++ programs. In C++ also, you can have a try block, you can have n number of catch blocks, but that's about all. Now, that creates a small problem, and let's talk about that problem. Please try and understand that problem, and then we'll talk about how that problem is rectified in Java. Now, imagine, okay, maybe I'll use the open board. please understand the problem. If you understand the problem, your solution will be automatic. So imagine there is a try block, okay, and let's say hypothetically there is open database as first line, and this is DBH, database handle, gives you an open database, and then there is a bunch of code, and after that there is a catch block, there is a catch of one kind of exception, there is one catch block. I am not even getting into what kind of exception, some exception. Again another catch block and its exception, another catch block and its handler. So this is the story of the code. Technically this code is correct, but now I have put a line here, let's say, called close database connection, close DB. I have put that line here. Now let's see, can you see what's perhaps inadequate or wrong in my code skeleton that I have written? Can you spot something strange, something wrong about the way I am writing my catch blocks or the way I have written the code? I am sorry, once again.
We should not close the database in the try block.
Why?
If we have an exception, then it won't
No, we can close it, but there is a problem with that. So now imagine between that open DB line and the closed DB line, there was some exception. Some exception was there. What will happen? I will not come out of the try block normally. Yes. So I will abort the try block for sure. We just saw that re-entry is not possible. So the closed DB of the try block will never be executed. Agreed? So I will have an open database connection, but I have not closed it. I will go into catch block. Maybe one of the catch blocks will handle it or may not handle it, or let's say it will handle it. Let's say some catch block handles it, but still I have an open database connection which has not been closed. So sooner or later, if you have too many open database connections which are not closed at all, then sooner or later your database will hang, saying I cannot open the connection because there are not enough handles available. Each handle takes some memory. There is a limit on the number of handles. If the number of handles have not been given back, every time you try to run this program again, it gives a problem. It consumes one handle which is never released. So the close will release the handle, but close will be called only if my try block completes successfully. If I go to the catch block, the only solution I can have is, in each of my catch blocks, remember there are 3 here, in each of my catch blocks I have to put close DB, close DB, close DB. Are you with me? Now imagine I have one try block and let's say 20 catch blocks. How many times will I have to close the connection? 21 times. Once in the try block and once in every exception block, because any exception block can come. So I have to close it in every exception block. If I have to close it in every exception block, and imagine there are 20 exception blocks, that is catch blocks, I will have to close this database connection 21 times. I mean, one of them will be executed. Now is this not too much to ask from a programmer? That every time he creates a catch block, he has to ensure that whatever has been opened, it has been cleaned. This closed database connection is called cleanup code. In a generic way, we call it cleanup because it may be closed database connection, it may be closing a file handle, it may be closing a socket connection, it may be closing some kind of a request, it could be anything. Cleanup code can be of any kind depending on what resources you are needing in the try block. Depending on what you have needed in the try block, you have to release them in the code. So if my try block has those lines, but what about catch blocks? That means each catch block will also have all the cleanup code and 20 catch blocks, 20 cleanup code. And if the programmer by mistake adds a catch block in the middle of the night when jackals are howling and dogs are barking, and he forgets to do that, he will have a bleed in his program, a resource bleed. Okay? So the problem is, in C++, there is no other way. In C++, if I open a database connection, I have to close it in the try block, and I have to close it in each and every catch block, because I cannot risk having open database connections, because that leads to sooner or later problems in the working of the database. So I cannot have that. I have to release them. So in C++, if I was a C++ programmer, I will be forced to add that release or close database connection in every catch block. And this applies to all kinds of resources, including, as I said, database connections, file handles, network handles, image processing handles, whatever library you are using. For example, let's say you have used some kind of an API, you have an API key with you, and you have opened a connection with that API. You have to release that connection, isn't it? And if you don't release it, you will have problems. So all those kind of things you have to do in the try block and every catch block. Now that becomes an ordeal, and that is a sure shot way of introducing bugs, leakages in your program. And that somehow is coming because in C++ there was no other way of doing it. You are forced to do it because I don't know whether I'll exit from a try block or I'll exit from whichever catch block. How do I know? Depends on how the program will run, depends on what exceptions I'll get. That will decide which catch blocks are there or not there. So I'll have to include this cleanup code everywhere, in every piece, every catch block, and that is too much to ask. Something easier has to be there. So what they did to rectify this provisioning of cleanup code, what did they do? They added in Java a new block called finally. What is the beauty of the finally block? Whether you exit from here normally or you come out because of the catch, anyone, there is no escape from finally. Finally is final. You cannot escape finally. So rather than adding my cleanup code here or here or here or here, I don't have to replicate it here, because finally there is no escape. Whether I come out normally or I come out because of some exception, because of some catch block, or even if I don't handle that exception, even then there is no escape from finally, and I can put cleanup code here. So this closing of database can be added here. You don't have to add it anywhere else. You can just add it in finally. And that makes your life very simple, because you can keep it in finally and only one place. That's it. Because what Java is saying, if you write a finally block, whether I execute normally, that there is no exception, or if there is an exception and I come to catch block, or I have an exception and either there is no catch block or the catch block doesn't catch my exception, even then finally will be executed. So there is no escape from finally, and finally is the best place or the only place you should use to write cleanup code. Cleanup code means releasing all the connections, whatever you have done, all of that can be given up in finally. That's the right place to give up whatever you have acquired in the beginning of the try block, because any sensible program will acquire some handles, some keys, something. Otherwise the program is not doing anything meaningful, right? So it will have to release it. Where should it release it? Finally is the reason for adding. So it was a smart addition in Java which wasn't there in C++. And now it's too late to add it in C++ because that language is cast, that part of the language is baked. It cannot be unbaked again. So that is gone. So we have it in Java where we have finally. So let's just check it out with finally. We will write normal code, we'll write abnormal code, we'll catch the exception and not catch the exception. So here what will happen is we will add a finally block. So we'll say finally executed, just to say that finally is not escapable. Finally executed. Okay, now we are going to have an exception which is going to be caught by the runtime. It's an array out of bound exception. We'll just check this code with different scenarios. First we are checking with an array index out of bound exception. So it will not be caught by arithmetic exception, but it will be caught by runtime exception because it's a base class. And then we'll have finally again. So let's try it here. Then we'll remove the exception and then see it. We'll see it in all possible situations. So let's see. Okay. Now 5, some runtime exception caught, 7. After that, finally executed. Finally could not be escaped. Finally executed. I'm just showing finally is coming every time. So this time the code try block came out with an exception. The exception was handled. Are you with me? And finally executed. Now let's see, there is no exception. So we'll say array 3, no exception. Okay. Still finally will be executed. That means you are coming out of the try block only. Okay. So you can, you see array access, that is after the successful array access, finally executed, exited normally, right? So now there is no exception. Earlier case there was an exception but handled. Now what we'll do is we will come out with an unhandled exception even then. So what we'll do is we'll comment out runtime exception. We can comment out anyone. So we'll comment out runtime exception and we'll add ARR 7 there. Make ARR 7. So now what is the situation? An array index out of bound exception will come. It will not be caught by the arithmetic exception. So my program is going to bomb out. No, yes. Because I am going to have an exception which is an array index out of bound exception. It is not going to be caught by arithmetic exception handler. It is not going, there is no other exception handler. So it will bomb out, but see what happens. See the output. You will understand what I mean. Okay, we are running it. Now just see. You see the output. File finally still executed. Are you understanding? This is important. Though I could not handle the exception, I did not handle the exception. The 5 came because of the division. After that, finally still got called. So whatever you write in finally, it will be called when there is no exception, when there is a handled exception, where there is an unhandled exception. Any of these situations, finally will be called. Okay. Now, do you understand finally? Okay. I am repeating. No exception. Exception is there, but handled. Exception is there, but not handled. Any of these scenarios, finally still executes. So it will still do the cleanup action, no matter what. So it's safe. Now this itself triggers a question, which is asked for the sake of asking, just to check how mature you are with Java. Is a genuine question which is asked is, so genuinely, is there no escape from finally? Meaning, can I somehow avoid finally? The layman Java programmer will say, no, no, no. Whether there is an exception, it will be caught. executed. Even if there is no exception, it will be executed. Even if there is exception and not handled, still it is executed. Finally, cannot be escaped. The obvious answer is, it can be, but that is not good coding, but I'll show you, because some people have this irritating habit just to finger you. Is it really finally will never be? Typical interviewer. Is it really finally can never be escaped? Always it will be called? Then you should tell him very clearly, nobody writes code like this, but there is an escape from finally. Okay. If you say exit, system dot exit, if you say, there is no finally, because the JVM itself closes. So when the JVM closes, nothing runs. How can finally run? So there is one caveat to this whole thing. It is an interview caveat. So what we will do is, after that exception, line 9, we'll say system.exit 0. That is a status of exit. So in this case, and only in this case, where your system decides to exit. Now, I shouldn't put it there. Okay. I shouldn't put it there, no? I should put it in. Okay. Let's put it there and see, because that line will never be encountered. Okay. So it should be above that. Now, okay, watch this. Still finally is executed, because that line was never encountered. I put it, but I put it before the exception. Okay. This is, just put it above the exception. Now finally will never come. No output, only 5. Are you clear? Did you understand? This is important. See, there is no finally. Why? Because I exited. This is the only way you can escape finally. Just say system.exit some status 0. 0 means normal exit. Okay. So if I put that line, you see there, line 9, then the code comes out, and in this special case only, there is no finally execution. This is not normally done, and this is not a good programming practice either. Nowhere in real life will you say system.exit. You are violating the basic law that the finally has to be there, and finally should be the last way that block goes out. Okay? So you are not sticking to proper programming practice by putting that exit, but I am just showing you. So we will comment it out right away and say that that is what it is. Okay? Done. Just remember this, that if somebody says, give me a situation where finally doesn't get called, even if it is there, this is the situation. Are we clear? Yes, no. So we have gone through try, catch, finally. Okay, there are some small things. You can have a try block with only finally block also. Rare, but possible. This is again interview question. They will give you a try block, not give you a catch block, and put a finally block. Most people will say, who are not very regular with Java, they will say no, because they wouldn't have seen such a thing, and it's very rare to put such a thing. But it is technically feasible, and it will compile and it will run. I can show you that. So we can skip the catch blocks. Go down. So we will comment out the catch blocks, and the code will compile and run. Try with just finally is correct, is allowed. Not correct programming practice, not good programming practice, but allowed. Okay, so we got finally, and we got an exception because we didn't handle it. Okay, but the code ran. Okay, now we are done with runtime exceptions. We understood how to do runtime exceptions. What are runtime exceptions? They are all derived from runtime exception class. We saw two of them. Which two? Array index out of bounds and arithmetic exception. There is one more interesting exception. Probably we'll just touch upon it and try to see it. Let's just do this, okay? Just so that we understand, because it's a common exception which a lot of people don't understand well. So I'll add, it is also a runtime exception, but I'll just do it where it comes, because there are certain important point which has to be understood about that exception. So we'll just go up a bit and we'll create a class base, okay, empty, and class derived extends base, okay. You understand what I am doing, right? Yes? Now I am going to create something in my code. Watch, I am going to get rid of that ARR 7, all that. Now I am going to say derived D, that is I am creating a reference of type derived. Derived D is equal to new base. Do you think this line is right? Do you like this line or not? What I am saying is this line correct or not? Not correct, right? No. It's a derived, what was the law? Base class reference can point to derived class object. I never said the vice versa is true. In fact, vice versa is not true, right? Derived class object, derived class reference cannot point to base class object, because derived class can have more methods. They cannot be supplied from a base class object, isn't it? So it's common sense tells you this is not possible. But I try to do this. This happens inadvertently with people who don't understand Java well or don't understand inheritance well. They do this kind of thing, okay? And now at this stage, the Java compiler will compile. No, first it will not compile. We'll make it compile, okay? Right now, Java compiler will say you have gone bonkers or what? Derived class reference, how can it point to base class object? Vice versa is allowed. This is not allowed. So Java compiler will shout at us. Let it tell us. We'll compile it. It will give us an error. Okay, let's look at the error. Yeah, can you go? Yeah, it will say something like incompatible types, base cannot be converted to derived. Now I looked at the line, okay, but I tried something smart. What am I trying to do? I know this guy is a base class object, and I know on the left side there is a derived class reference, but I tried to be clever, okay. Now see how I am trying to be clever. I am going to cast that right hand side reference into a derived reference, okay. So I'll cast it, that is I'll cast the reference into a derived class reference. This is called casting. What am I trying to tell the compiler? Whatever reference you are getting, convert it into derived class reference and give it to me. I will convert it into derived class reference, yes, no, and access it. Now let's see what the compiler says. Okay, the compiler compiles. No, are you understanding? The compiler compiled. What? You are so adamant, so idiot. The compiler, okay, compile. But when you try to run it, you get this famous exception called class cast exception. See the exception? It is called, there it is, class cast exception. It's a runtime exception. Java only checks for, if you are casting it, Java says enough. I have had enough of this. Let him face music at runtime. Okay. I tried to tell him, Baba, this is a derived class reference. You are pointing it to a base class object. It's not true. But this fellow is an adamant fellow, right? So let him, he's casting it. By just casting it, you can't solve the problem then. It's like, if there is a buffalo, if you make it wear the skin of a tiger, it doesn't become a tiger, correct? Have you tried that? That is what you are trying to do, no? Like a tiger. So what you thought very smartly, if I dress him up as a tiger, he becomes a tiger. Java compiler says, okay Baba, your way. But at runtime, JVM says, a buffalo cannot become a tiger. So then you get an exception which is called class cast exception. It's a wrong cast. Are you with me? We will not allow this task because a derived class expects more than a base class. A base class reference can point to a derived class object because anyway derived has everything which a base has. But a derived reference cannot point to a base class because from D I'll expect something more which base may not provide. So I will not allow this casting to happen. So it will give a exception. This is also a popular runtime exception. It comes very often in programs and very often people don't understand why that exception is coming. So, okay, now we have this exception, but this exception shows up in many ways, many times. And the problem is, this is a runtime exception. So it's not mandatory to put a catch block. If it was a checked exception, then we would have spotted it and code won't have compiled. So just watch this. This comes very often even in other packages. Even Unreal has it in C++. This happens in C++ also. Same problem. You cast it and compiler forgives it and runtime you face the music. Okay? So be very careful about this exception. This is a very common exception and you now know why it comes. It comes because you are expecting something from a base class. Whenever you think of this exception, think of trying to make a buffalo into a tiger by putting the skin of the tiger on it. It will not become. Okay? So just think of that whenever you see a class cast exception. It's not allowed and that's the reason this exception comes. It's very important exception. Okay. Now we have seen some 3 popular runtime exceptions. Now let's turn our attention to what are called checked exceptions. Okay? So I can choose any exception class. I am going to choose one of them because I am not expecting you to know database handling at this stage of Java because we haven't covered JDBC. We'll cover it later and then another class of exceptions will come which are SQL exceptions. But not right now. Right now we will try to open a file and that file won't be there and we'll get a file not found exception which comes in IO exception, but it is a checked exception. So just see the behavior, how you do that. Okay, but before that, let's just go to Google and check how do you open a file. You can also check how do you open a file. File is a file on the hard disk, anything. Okay, how do you deal with that? So the file has to be created. If you are having Java standalone, you can work with it, but if you are doing it in Telescope, we'll pause to see, we'll create a file there and just to check whether that file is there or not. Day 12 Java Lab 2. That is available to that program. Day 12, please close this, open that. Yes, no? Because that program has access to that. We have created one file on the hard disk in Amazon so that you can all access it. Okay. Now, the name of the file is file1.txt. Now, if I am going to deal with files, I have to import that package called java.io.star. Okay. That package enables me to deal with files and all IO. So, you have to import java.io.star. Are we clear? No, yes. Otherwise you can't deal with files. Files are all with IO package. So I have added that line java.io.star so that I can work with files. Now the way you work with file is, first you have to create a file object. So the file object can be whatever the name of the file. Okay? File1.txt. Then you have to open the file for reading. We'll open the file for reading. This is just creating a file object. It does not create the file. Are you there? It just creates a file object in our program associated with that file on the hard disk. That's all. Now, this is how you open the file. You open it using a buffered reader so that you can read line by line from the file. And then you say new file reader. This is how you do. I'll explain this in a moment. F. Okay. Okay. Let me explain this line. Okay. This is called chaining. First you have to create, if you have to read data from a file, F, first you have to create the file object, which we did in the first line. After creating the file object, first you have to create a file reader, which will enable you to read characters from the file. But the problem with file reader is, it will only allow you to read character by character from the file. It will not allow you to read line by line from the file. So if you are happy with only reading character by character, file reader is good enough. But if you want to read line by line from a file, you cannot use a file reader. You have to take that file reader, give it to buffered reader. So buffered reader, what it will do? It will read character by character internally, but it will give it to you in line form. So it will read, when you read from the buffered reader, you will get lines. When you read from the file reader, you will get single character. So if you generally, most programs, they like to read data as lines, isn't it? And we would then process one line at one go. So if you want that, you have to use a buffered reader, because it will buffer all the data in all the characters up to new line and give it to you in one chunk. So buffered reader. Now, how do I read from the buffered reader? This is how I read. So while, no, first we read one line and then check null, no? String line, okay, string line is equal to br.readLine, br.readLine, line not equal to null, or while line actually. You can just say while line also. It automatically checks whether it's null or not. So while line, system.out, I hope most of you will understand what this program is doing. SOP, print that line and read the next line. So again say line is equal to br.readLine. Keeps doing this till line is not null. It's a small loop. Did all of you understand what I am trying to do? It's not difficult. Yes, no? What am I doing? First I created file object on line 5. Okay? Just the file object, nothing to do with the hard disk yet. Then the file 1.txt should already be there if this program has to work. It's already there, we created it for you. Then new buffered reader, first create the new file reader. It will give you a reader object, file reader object. Pass that reader object to buffered reader. It will give you a buffered reader object, which I told you the difference. Then you can read line by line from the file. How? Just say br.readLine, it will give you one line from the file. While line means if that line is not null, that is I was successfully able to read a line from the file. Then I'll print the line and assign line to read the next line. This is how it goes on till everything in the file is read and you get a null. When you get a null, you come out. Then at the end, after you come out, after while loop, you can close the file. So you can close the buffered reader, which will close the file. This is a good habit. Normally this code will go into finally. No, yes. But for that you have to take the BR and make it a general reference. Okay. So now, watch. Is this program looks okay? Do you understand what this program is trying to do? Yes? Now, this is where the difference between unchecked and checked exception comes. Now, let's just think about this. Let's not run it yet. Let's just think about the program we have written. The underlying thing you must understand is, even though my program was buggy, my program did run. That means my program compiled and it executed. It is at only execution time, at run time, that I face the music if I had not handled exceptions. Correct? But now you will see the difference. Those were unchecked exceptions. That is, the Java compiler says, do what you want. At runtime anyway you will have the problem. For checked exceptions, which are other than those few exceptions, Java says, now just watch what Java will say. We'll try and compile this program and try to compile this program. Okay. Now, while line, okay. Just say while line not equal to null. It's giving it's expecting a boolean. Okay. I thought that will work. Okay. This error is something else. Okay. Now, see the things. Now just observe. See the way Java is getting upset now with this code. He's saying, you are making lot of assumptions which you are not bothering. Okay. Now, this is where the checked exception idea comes up. He's saying on line 6, he's saying you are creating a file reader, assuming that you have a file like that. Where are you handling file not found exception? You are not taking care. There is a possibility that the file will not be there. Where is your exception handler for file not found? Are you taking care of that situation? You are not. You are telling me that you are opening a file for reading, but what if the file is not there? Have you in your program made provisions for handling an exception which may come? Remember the difference. Earlier also this possibility of problems was there, but Java allowed your program to run. Now Java is saying, no. Show me where you are handling these exceptions. If you are not handling these exceptions, I will not allow you to compile the program. You may be a completely idiot. You don't even know that there may be an exception here. You have written this code. You are completely unaware of the possibility of exceptions. I will not allow you to program this, to compile this. So he's saying, see that on line 6 he's saying that file may not be there. Then he's saying the read line may never work because the file may be empty, and if you do read line on an empty file, what will happen? You will get an exception. You are not handling that exception. Where is the handler for that exception? You are not having it. And then on closing, again the file may not have opened itself. How will you close? Why are you putting close code without checking whether it is open or not? So all these are problems which are there in your program, and you are handling none of them. You don't even are aware that there is possibility of so many problems in your code. You are not even aware. So this is what, now just let's look at the name of one of the exception he is trying to make you aware of. File not found. Okay. Let's look at its hierarchy. You see there is a possibility of file not found exception which is neither caught nor have you even shown a cognizance of that exception. So now just see file not found exception. Can you see its hierarchy and compare that hierarchy with some of the earlier hierarchies we saw? Do you see any difference? No, yes. Do you see any difference? No, I am saying at a conceptual level, are you able to see the difference between the exceptions which we saw earlier and what we are seeing now? What is the difference? Good. So that makes it a checked exception. See, nowhere in its hierarchy, you are seeing the exception file not found. Do you see runtime exception anywhere in the hierarchy? So they are not part of the runtime exception hierarchy. any exception which is not part of the runtime exception is called a checked exception, and it is the duty of the programmer to tell the compiler how I am going to handle it, or the programmer's job is to convince the compiler that I am aware that there is an exception and I am taking cognizance of that exception. Cognizance means I am expressing awareness about that exception. I know that there is an exception. The compiler needs some kind of assurance from you, some kind of acknowledgement from you, from the programmer, saying, Mr. Programmer, I am just checking, are you from Andhra, Telangana, where? I am just asking you a simple question. You tell me whether you are smart, because you are not giving me any assurance about file not found, about IO exception, anything, nothing you are telling me. It appears to me that you are a complete novice. You just don't know that there is possibility of this exception, because your code, the way you have written your code, doesn't reflect any maturity with these exceptions. You have to give me an assurance, otherwise I will not compile this code. This is where Java becomes very strict in its compilation. It says, no, you can't compile this code because you have not shown me any proof that you are aware of these exceptions. These are called checked exceptions, because Java compiler now checks. Earlier it was forgiving. With runtime exception hierarchy, it is forgiving. You catch, you don't catch, I'll compile, you face the music. Now, compilation itself doesn't happen. I'll block it right now here. Okay. Now, how do I make the Java compiler happy? There are two ways. What are the two ways? Either I handle the exception, or tell the Java compiler, look, I know there is an exception, but I have chosen to ignore that exception. Somehow I have to tell him. Okay. We will do these two and stop. Okay. Now, what we will do is, I will do the regular way. I will put this in a nice try block, and I will put all this code in a nice try block. No, put the whole thing in try block. We'll look at BR close later. Yeah. Or remove the BR close for the time. Okay. Now we catch. Now we can decide what we can do catching. Okay. You can catch these exceptions independently. What are the exceptions expected? Look at the error messages. The exception expected is file not found exception, yes, and in all other cases IO exception. Now I can write two handlers, one for file not found and one for IO exception. But if you look closely, just show the hierarchy again. File not found and IO exception. Okay, now look at the class hierarchy again. You will notice that file not found is also derived from, can you see that? IO exception. Can you see that? No, yes. File not found is derived from IO exception. It's there in the chart, right? So what does it mean? What does it mean? It is not necessary to catch both the exceptions. If I catch IO exception, will it not be like a generalized exception handler? Just like we caught runtime exception, we didn't have to catch arithmetic or array index out of bound. Base class exception, if you catch, then base class exception can be assigned to any derived class object. So if I catch only IO exception, it is enough. Or if you want, you can first catch file not found, then catch IO exception. That also you can do if you want differential treatment. But if you want generic treatment, you can catch one time IO exception. So let's do that. So we can say catch IO exception IE, and we'll say print line IOE dot get message. So we caught it, we are catching it. This is one way. But remember, unless you put this catch line, your code is not compiling. This is important to remember. This is because the kind of exception coming in that line, expected exception, is a checked exception. Then it is forcing you to put a catch block. Now I'll try and compile. Yeah, and this is our program has run and it has produced some output from that file. He put some junk in that file, so that is the junk we are seeing on the screen. Okay. You can also see something. Okay. Are we clear? No, yes. Did you understand this program? No, yes. Do you know, this is some output which is coming from the file. Don't worry about what out. Something. Okay. Clear? Okay. Now, this is one way of handling an exception. Okay. What is this way of handling an exception? I wrote a try block and I wrote a catch block. So I made the Java compiler happy. I know there is a checked exception. I know there are two kinds of exceptions, file not found and IO exception. I have written a generic handler. I am done. There is one more way of handling. That's the last thing we'll talk and we'll stop. Okay. So I am going to remove that catch block and the try block. Now you will say, now the code won't compile. Correct? Yes. The code won't compile. Correct? Because again Java compiler will say, you don't seem to acknowledge any of the exceptions because you have not put a catch block. There is another way. This is called, the second way is called ducking an exception. Ducking. Ducking means, if those of you have played cricket. Now, in this program, one way is to catch an exception, which we just saw. We write a try block and a catch block. Second is, tell the Java compiler, I am Sunil Gavaskar, you are throwing Joel Garner at me, I will duck this exception. That is, don't catch it, just tell the Java compiler, I know there is an exception, I am not going to handle it, I am going to duck it. So you can do it like this, no handling, just at main, the method which is using it, just add a word, throws. I am telling that my method can throw an exception, I am not catching it, but I am telling the compiler, I am aware. I know that there is a possibility of an exception, I just don't want to catch it, I want to duck it. Throws IO exception. Just put that line, that is not a good code, you should catch. But I am just showing you for checked exception, what is the other way of allowing your code to compile. Okay? This is throws IO exception, that's it. I declare, this is called reporting an exception, not catching an exception. You either have to catch it or you have to report it. I am reporting an exception. I am telling the Java compiler, I know Baba, there is an exception which is a checked exception. I am assuring you I am aware. I am not catching it, that's all. So Java compiler says, okay, you are a nasty guy, you are not catching it, but at least you seem to be aware of it. Even now, the program will compile and run, and because there is already a file, there will not be an exception. This is like making it into runtime exception in a way. So we got the output. Did you understand this trick? No, yes. I just declared at the top of my program main, throws this exception. I did not catch it. So either of these two techniques I have to do for checked exception if my code has to compile. What are the two? Either I catch it, try catch it, or that's the correct way, or I simply duck the exception. I just say, I'm not interested, whatever happens, happens, I'm not bothered. So that is how you say reporting an exception. That is called throws. Same exception. Okay, so that is what we are, and that is where we will stop. So we have gone through a lot. We have understood what are exceptions. We have understood what are runtime exceptions, what are checked exceptions. We have seen try, catch, finally. Now what is left in exceptions is user-defined exceptions, which is what we'll do next. And then he will give you an exercise to do so that you can become comfortable. Okay? So this is what is half the story of exceptions. The other half we will talk about next class.